Okay, good morning. Welcome to
FamilyMath323.
FamilyMath323. So we're going to continue on our study from yesterday on this game called Checker Stacks that I learned about in Jim Prop's blog. Okay. And can you tell me a little bit about what you remember about Checker Stacks?
Well, you have some blue checkers and some red checkers, and you can stack them on top of each other. You could even have some blue-red stacks.
Okay.
And you take turns removing some checkers from the board, and then whoever, the blue or red cannot remove a checker, then they lose.
Okay. Do you have anything else you want to add to that?
Not really.
Okay. So one thing that was that made this game interesting is that you could assign numbers to the positions. And we said a single red was what?
Minus -1.
And a single blue?
Is
+1. And it turned out that if you found the number that represented the position, if it was positive, blue would win no matter what.
And if it was negative, red would win.
And if it was 0, what would happen?
Whoever went second would win.
Okay. So this position, for example, is a -1
And
plus a +1, which is 0. So in this position, whoever goes second wins. Do you see why?
Well, because if red goes first, red removes this, blue removes that, and then red can't remove anything.
Very good. Okay, so today we're going to study 3 interesting new types of checkers and learn about their properties. And do you remember what happens when you learn about the surreal numbers?
Your brain cracks open.
Yeah, your brain cracks open. So get ready for that. So Jim Prop calls these new checkers deep blue, which I'm going to represent as a black position, deep red, which I'll represent as one of these orange checkers, and deep purple, which I'll represent as
Purple.
purple. Okay? So let me first explain what a deep blue is. A deep blue checker has this property. Blue can remove it and replace it by a finitely tall stack of blue checkers, including no checkers. So you could remove it completely. Okay? So you could remove, it's blue's turn, blue can remove a deep blue and replace it with, for example, a stack of checkers 3 high. Or a stack of checkers how high?
Like a billion high.
A billion high. Or a stack of checkers
Graham's number high.
Graham's number high. Or a stack of checkers
Google high.
Google high. Interesting. Very, very interesting. So let's see if we can find what number you would associate with a deep blue. Okay. So the first thing we're going to do is study this position. Deep blue versus red. A single red. Okay. What would you do if you were blue here and you were going first?
Well, I could remove a deep blue and put, like, let's say, 3.
Okay.
You can put as many as you want, really.
Okay. Yeah. But
And
I'm
then-
just seeing what he would want to do here.
Then red removes this. You can remove either. You can remove any one of these.
Well, but if you remove the bottom, remember all of it goes away.
Yeah.
Yeah. If you remove this, then red can't remove anything.
Aha. So who wins?
So blue wins.
Looks like blue wins.
You only need to stack. You only would need actually 1 blue checker to win.
Very interesting. Okay. So in this case, blue wins. So this position must be positive, right? So whatever this is, whatever the value of this is, this -1 must be positive. Okay. Let's try the game against deep blue against 2 red.
Well, here you could just replace it with quite a lot of blues. You just need to have more blues than they have reds. So here red takes, you went first.
Yeah.
You replaced it with this. Red takes this away. You take the top one. That's the smart thing to do.
Okay.
Red takes this away. You take the top one. Red can't take anything away.
Interesting. So blue wins again.
So
So that means a deep blue must be worth more than 2. right? Because this
Yeah.
position must be positive, and it's whatever deep blue is minus 2.
But then the same would be true for 3. You could replace it with a number higher than 3, and then higher than 4, then higher than
Yeah,
5.
you could have any finite number of reds on here. And then all you need to do is replace it with that many finite number of reds.
Plus 1.
Plus 1. Well, actually, no, you don't even need the plus 1. You can just replace it with the same number because your turn is taking away the deep blue and replacing it. So for any finite number of reds you have, blue wins
Interesting.
when you have a deep blue.
So the value of this deep blue is bigger than any finite number.
Which means it's infinity.
It would have to be positive infinity.
Interesting.
Infinity.
Did you ever wonder what infinity looked like?
A deep blue.
There it is. That is what infinity looks like. Interesting, huh?
Yeah.
All right. Let's learn about deep red.
Okay.
Okay.